guys, welcome to Algebra 2. First we're going to start, I just want you to kind of warm up by doing the 5 multi-step equations that are at the front of your notes packet. I have given you some reminders. The goal of equation solving is of course to isolate the variable, so get that variable by itself so we can find out its value. So again, make sure that to do this, you distribute. If there's any parentheses, you combine like terms that are already on the same side. If there are variables on both sides, you need to get them on the same side by adding or subtracting them. That's where we get into do the same thing on both sides. Then adding or subtracting, again, to do the same thing on both sides to move the constant. And then multiplying or dividing by the coefficient. Typically, it's going to be dividing. A lot of times if there is a fraction, that's when we would need to multiply, and often we will do this at the beginning instead of at the end. So those 5 problems, I just want you to, they follow this in the review. I'm going to scroll down to those so you can have a chance, if you don't have your notes yet, to get them written down. And if you don't have your notes yet, please make arrangements to come to school to pick them up. They're just on a table with Miss Denise there at the front. So you can stop by anytime school's open to pick them up or contact me about getting them. So here are the first, I guess you can see the first 3 at this point. So I'm not going to go over these. I want you to work them, and then I will put my work up, and you can check your answers. So there's my first 2 answers. I got 5 for number 1 and -8 for number 2. Remember, you should always be able to plug a number into an equation to check solutions. So if I got 5, I should be able to do 2 plus 5 times 5 is 25. Minus 1 times 5 is 5, should equal 22. 27 minus 5 does equal 22. Check, check. -8 down here, 3 times 4 times -8, right? 4 times -8, since -8 is x, -32 minus 10. This should give us -126. That's -42. Times 3 is -126. So -8 also is correct. Here are your next 3 problems. So put me on pause, give those 3 problems a try, and then magically when you start playing again, you will be able to see the answers. All right, you should see my answers at the left, 5, 2, and 0. Now, I may have not shown as many steps, or I may have not shown like +5 on both sides, but we should still have the same answers. So that's some review. That's why I called that a warm-up. All right, so the next thing you should have in your notes there, we're going to talk about absolute value. And you may have talked about absolute value in Math B, or I may have mentioned it in Algebra 1, but we're actually going to be solving some absolute value equations. It's going to be important that we just understand some basic things about absolute value first. So these 2 bars, when we see this absolute value of x, so it's just how far away is x from 0. That's all that means, is how far away from 0 is that x. So both a negative and positive number have the same absolute value. Both 5 and -5 are 5 spaces away from 0. It's like saying, how far am I from Muncie? I don't care which direction. I'm just asking how far. So if it's a positive number and you see it in absolute value of 15, is just 15. Absolute value of negative 7 is 7. It does not mean opposite. Okay, opposite, we always change the sign. Absolute value is always expressed as a positive number. So you're going to have a chance to, sorry about that, do a few here at the bottom. So try these. They also act as grouping symbols. So if there's more than one thing inside absolute value, then you want to do what's inside and then make the answer positive. So for instance, if I have negative 17 plus 12, the absolute value of that, I do not change them both to positive. I put negative 17 and 12 together, I get negative 5, and then the absolute value of negative 5 is 5. So treat them like parentheses, and then know that when you get rid of the bars, then you make it a positive. So try the ones at the bottom, and then we'll see if we agree. All right, I got 15, 23, negative 9, and 3. So 15, 23, negative 9, and 3. So this third one is negative because the negative is on the outside of the absolute value. So it's like we're saying the opposite of that absolute value. Or you could think of it as negative 1 times the absolute value. So then it does force it to go back to a negative. So you're going to have a chance to practice this on IXL. And if you happen to be listening to this in another term and we don't use IXL, then you'll have a different kind of assignment. But down here at the bottom of your notes, you'll see that our first assignment should be a pretty quick assignment. Lesson algebra, and we're going to do that from the Algebra 1 tab. Most of our things will be from Algebra 2, but there will be a few things we use the Algebra 1 tab. I will make recommendations, so that should not be an issue. You should see those in your recommended lessons on IXL. So I'm going to show you a few examples there just to help you be prepared. So you're going to want to make sure that you actually read the question. This says, what is the opposite of 5? So negative 5. Change the sign for opposite. What is the opposite of 4? Negative 4. The absolute value of negative 4, that's like it's in the bars. How far is negative 4 from 0? 4. The opposite of negative 5, 5. The absolute value of negative 7, yep, positive 7. The opposite of 2, so opposites can be negative, so that's negative 2. The absolute value of 1/3, so still 1/3, we type that with a slash, 1/3. Most of you are familiar with how we type this on IXL. The absolute value of 7.1, how far is that from 0? Still 7.1. So as you can see, this should go very quickly. You could probably go higher than 80 if you like, but you are still only required to go to 80 on this lesson. Absolute value here. So it looks like I got 10 questions. Now I got all of them right, so I'm almost finished. This mixed number, 96 space, whoop, that's not space, space 5/6. So same kind of thing. So no big surprises there. That should just take a couple minutes. Well, maybe 10 at the most. I had actually gotten on the lesson before we started going through the questions, so that's why I'm at 7.5 minutes. So at that point, you might be saying, gosh, I think I did that back in Math B. This is so easy. I thought Algebra 2 was going to be hard. It gets harder, but we need to know that first. All right, so that's step one. So now we can also evaluate expressions that contain absolute value symbols. So remember, expressions don't have an equal sign yet. We're not talking equations yet. And it says if x is equal to -2. So that means we would be plugging in -2 for x. And this is going to be important because knowing how to do this is going to allow you to check when we're doing equations. So 9 times -2 is -18. Notice that plus 5 is just hanging out on the outside. -18 and -3 give us -21. So absolute value of -21. So I do everything inside first. Then I take the absolute value. So then that's 21 without the bars now, plus the 5. Final answer is 26. So when we're checking our absolute value problems, it's going to be important. This is basically what we're doing on each side of the equation to be able to check that. So this is our big new thing. All right, now we're solving an equation and it has absolute value bars in it. So think about if we had a very simple equation that said the absolute value of x is equal to 3. Well, if I had a simple equation that said the absolute value of x is equal to 3, there would be two solutions. X could be 3 or x could be -3. So we're going to see that we're going to have two solutions on almost every absolute value equation. So here I have x plus 8, absolute value of that is equal to 3. So when we do that, we always want to first get the absolute value part by itself, which in this case it is by itself, right? There's nothing on the left side that's hanging out outside the absolute value. That's what I mean by getting it by itself. Then we make two equations. So my possibilities here are that x plus 8 is equal to 3, or x plus 8 is equal to -3. Because if the answer inside was -3, the absolute value would still be 3. And then I solve both of these equations like normal. So then whether you just do this in your head or you write it down, we're in Algebra 2 now, so you're going to see less times that I write what I'm writing in red. Sometimes I'm not going to write that anymore. Doesn't mean you can't, but that I trust that you can follow me if I don't. So my solutions are -5 and -11. And then I could test those. -5 plus 8 is -3. The absolute value of -3 is 3. -11 plus 8 is -3. Sorry, I think on the first one I may have jacked you up a little bit. -5 plus 8 was +3. And the absolute value of +3 is 3. Sorry. And -11 plus 8 is -3. Absolute value of that is 3. They do both work. So, sorry, I got ahead of myself on getting the negative number first when actually that one gave us the positive. It is going to be important, though, that you get the absolute value by itself first, or one of your answers is always going to be wrong. All right, a couple more problems here at the bottom of the page. Remember, you're getting that absolute value by itself. In this case, we're multiplying, so if you forgot to do it at the beginning, it doesn't bite you quite the way it does if it's adding and subtracting. So if I multiply both sides by 9 to get rid of that fraction, then I'm going to have absolute value of 6x minus 6 is 36. And then that becomes two equations. One of them it just stays the same without the bars. And then the other one, I make that a negative 36. So the one with positive 36, one with negative 36. I add 6 over here, I get 42. And then divide by 6, and x is 7. And then over here, if I add 6 to negative 36, I don't get negative 42. Nope, nope, no, because signs are different, right? I get 6x is equal to negative 30, and I divide by 6, and I get x is negative 5. So please do not think that the two answers are always opposite each other. It is actually rare that that is the case. So looking at my other problem down in the right corner, the negative 9, I hope you're not tempted to add 9, because that negative 9, it is jammed right up next to that absolute value sign. So just like if there was a number next to parentheses, right now it indicates multiplication. So to get rid of it, I need to divide both sides by negative 9. And now we have x over 10 is equal to 1. And then when I get rid of the bars, that means there's one possibility. And there's my other possibility. Multiply by 10. And in this case, because it was all multiplying and dividing, no addition and subtraction, my answers do turn out to be opposites of each other. That will only happen if it's only multiplying and dividing. If there's any addition or subtraction anywhere in the problem, that doesn't happen. And again, all of these you can plug in to check. So go ahead and take a minute to do the problem that's on the next page of your notes. Be sure that you get the absolute value bars by themselves before you split it in two pieces. In case you don't have your notes yet, here is that next problem with my reminder. First, isolate the absolute value. So basically treat the whole bars like this is one giant X. So first, you're basically treating that like it's just one giant X. Kind of like this is all just one big giant X. Do what you would have to do to get that by itself. Then you put it into two pieces. So I have gotten my absolute value bars by themselves. Now I'm ready to split it into two pieces. So now I do 3x minus 1 is equal to 14. And 3x minus 1 could be equal to negative 14. Now I have two two-step problems to do. And if you notice, if I had changed that 33 to negative 33 first, I would not be getting the same answer. So it does matter that you get the absolute value bars by themselves first, anytime there's any addition or subtraction involved. So I'm going to add 1. Then I'm going to divide by 3. I'm going to add 1. And I'm going to divide by 3. Now, it is going to be very common that one of our answers is not going to be pretty. Okay? So don't be holding grudges against improper fractions. This guy is a beautiful answer. Okay, he's a little bit of a pain to try to check, but remember if you did 3 times negative 13 over 3, the 3's would cancel and make negative 13. So, and if that happens, I do not want you to make it a decimal. Only use a decimal if it comes out perfectly even. If you have to ask me, should I use a repeating bar? Or how many places do you want me to keep? Then I don't want you to use a decimal. Okay, so for these problems, just like in Algebra 1, If things didn't come out evenly, I want you to, the improper fraction is good. If it could be reduced, you would reduce, but in this case it doesn't. So you saw at the top of the page that we have IXL lesson. So we'll go there, and you can write down a couple examples down at the bottom where it says additional examples. All right, just joking. I actually already gave you a couple additional examples. A couple that people sometimes get pretty tripped up on because they want to jump in here and do 9 plus 4. You cannot jump in here and do 9 plus 4 first, because the 4 means multiply, and multiply happens before addition. So it's going to be important that, we undo things. Remember, we're supposed to get that absolute value by itself first. So when we go to undo things here, we need to be subtracting 9 on both sides first. Then I have 4 times the absolute value of 9a minus 8 is equal to 4. Then I divide both sides by 4. And coincidentally, in this particular situation, it would turn out the same. But that is not normal. Okay, that's not what would usually happen. So here I have 9a minus 8 is 1. And again, that would still be an absolute value. So our two equations that we would work with would be 9a minus 8 is 1, and 9a minus 8 is negative 1. So on the left side, when I add 8, I get 9a is equal to 9, so a is equal to 1. And on the right side, when I add 8, I get 9a is equal to 7, and I get a messy answer of 7 over 9. So my two solutions, a is equal to 1, a is equal to 7 over 9. You will have two solutions. Okay, so you can try the one on the right. I am going to go over and grab a couple examples. These are going to be some of the harder ones that you'll see, but you will have ones similar to these that will be on your quiz at the end of this unit. So I wanted to be sure that we had practiced a few of those. Most of your problems on IXL are going to be easier than these problems. All right, so here we are in IXL. We're on the Algebra 2 tab, lesson B4. So again, it should be in your recommendations, but Algebra 2 tab, B4. And IXL is not going to let you forget that there's two solutions. You've got two boxes to fill in. On the rare occasions that they are the same answer, then you're going to just type the same answer twice. I don't know if we'll get any like that, but just in case. All right, so 6 is equal to absolute value of 3y. So the absolute value bars are already by themselves. So then either 6 is equal to 3y or negative 6 is equal to 3y. So it's that number outside the bars that we use that number, and we use its opposite for the second equation. So now I'm going to divide both sides by 3. I get 2 is equal to y. Divide by 3, I get negative 2 is equal to y. And that's what I'm going to type in, is 2 and negative 2. It does not matter which one you put in the left box or the right box. So 2, negative 2. So now this time, the absolute value bars are not by themselves. We have to get that by itself first. So absolute value of u plus 5 is 9. Take away 5 on both sides, becomes the absolute value of u is equal to 4. So then u is either 4 or u is equal to negative 4. Now, you might be saying, well, why can't I do the other thing first? Well, let's see what happens if you tried. So if I tried to do the other part first, if I went ahead and made this 2 equations at the beginning, I'm going to put this in red at the bottom because it's not right. And then I did this, and I said equals negative 9. This one would turn out the same, right? I would still get u as 4, but over here, I'm not going to get negative 4. I'm going to get negative 14. So when I see people are giving 2 answers, and one of them is wrong, one of them's always right, but one of them's wrong, it's usually because they're forgetting to isolate the absolute value first. So be sure, get the bars alone first before you split it into 2 parts, before you do that opposite step. So here, 4 and negative 4. So 4, and negative 4. Right, I'm going to jump ahead to get something a little harder. So some of these are going to ask, how many solutions does it have? The possible answers are no solution, 1 solution, or 2 solutions. So remember that absolute value always is a positive number. So if we start out with something that's inside absolute value bars, and we say it's equal to negative 5, negative 15, whatever, the absolute value can't be a negative. This is automatically a no solution, because absolute value can't be a negative number. Now, if the absolute value is equal to 0, like in this case, so this is an example I wrote up here that would be a no solution. If the absolute value is equal to 0, think about what happens when we break this up. What's the opposite of 0? There really isn't one, right? How far away is 0 from 0? 0. Doesn't matter left and right, right? So if the answer is 0, look what happens. I get the same answer twice, which means there's really only one solution. So no solution is when we have absolute value equal to a negative. Absolute value equal to 0 is going to be one solution. And then our other situations are going to be 2 solutions. Keep in mind, like the equal to 0 is after the bars are by themselves. So in this case, I have one solution. So for this question, whether I solve it or not, you may be able to look at it and go, it's going to be 2 solutions. If you try to work it out, that should be what you find. That either 3 is equal to q minus 2 or negative 3 is equal to q minus 2. So my answers are 5 and negative 1. So there are 2 solutions. Again, since the absolute value bars are by themselves and it's equal to some number, some positive number, okay, so once the absolute value is by itself, if it's equal to a positive number, it's going to have 2 solutions. If it's equal to a negative number, it's going to have no solutions. So absolute value bars by themselves, This negative gives me no solution. 0 gives me 1 solution. And positive number gives me 2 solutions. All right, we finally get a question here as another example where we're going to have to do 2 steps, and we do need to get that absolute value by itself first. So first step is going to be to add 8 to both sides. So like if I was writing down things on scrap paper, this might be the first thing I'm writing down, that 27 equals 9g, and negative 27 is equal to 9g. So I just went ahead and split it up. Remember, I don't do positive and negative 19. I wait until the absolute values are by themselves. Then divide by 3, or 9, I'm sorry, and I get 3. And then over here, when I divide by 9, I get negative 3. And once again, you can always check your solutions by plugging them in. 9 times 3 is 27. 27, absolute value is 27. 27 minus 8 is 19. So in this case, 3 and negative 3. All right, so for this problem, if you need to decide if there's no solution, 1 solution, or 2 solutions, first get your absolute value by itself, okay? So get the absolute value by itself, which means I'm going to have to add 5 to both sides. Then I would have absolute value of negative b is equal to negative 4. The absolute value cannot be equal to a negative by definition, okay? So that means absolute value by itself equal to a negative. That's a no solution. Don't worry about what's inside those brackets. It doesn't matter. It cannot, inside the absolute value bars, if there's nothing else going on the outside, right? It's by itself. Once it's isolated, it cannot equal a negative. That's when there's going to be no solution. All right, so again, you want to get the score up to 80. And so now something that might have looked intimidating because it had those new symbols, you realize not such a big idea. It is twice the work because you are solving 2 equations. All right. Lesson 1.